Hello everyone. Today we are again with some new video. Today we are going to talk about one-way ANOVA, which is another kind of parametric test. Let's start with one-way ANOVA. We are doing ANOVA in Excel. On the screen, you can see a question like there are three performance of three different cars in terms of their mileage has been given. And they have said that the following are the number of kilometers liters with the test driver with three different types of car has obtained randomly on different occasions. Using 5% level of significance, perform a one-way ANOVA to examine the hypothesis that the difference in the average mileage in three types of car can be attributed by chance. If we want to simplify this question in a most simplest manner, I want to define it. In the question, they are just given the performance in terms of the mileage of three different cars. And you can see that even N is not matching in any case. That is not important or required condition for performing one-way ANOVA. So every time N could be different, as in this case you can see. So what they are asking you that car 1 has some average mileage, car 2 has some average mileage, and car 3 have some average mileage. So they are asking you to check whether all the three cars have the same average, or if it is not the same, then is it significantly different from each other or not. So like any other hypothesis testing, we start a question with setting up the hypothesis. So in this case, my null hypothesis would be, you can take a clue from the question also that what could be the null hypothesis, as they're saying that one-way ANOVA to examine the hypothesis that the difference in average mileage in the three type car can be attributed to chance. So you can say that there is no significant difference in the average mileage of the cars. Accordingly, we will create the alternate hypothesis which will state that there is a significant difference in the average mileage of the cars. So the first part is ready. Now second part, step 2 is always about setting up the level of significance or defining the level of significance. So in our case, level of significance is given in the question, which is 5%. So in some books, it could be written that define the critical region, or we are saying it level of significance. So all are same or interrelated. Now step 3 is to perform the test. Now when you perform the test, here we are going to take the help of software. So going back to the system, the same menu, data menu, and within data menu, we have data analysis. Within data menu, we have data analysis tab. Let me try again. I don't know why it's not working. I'm going to data. Within data, data analysis. And here we are going to opt the option ANOVA single factor, which is the first option given in the analysis tool drop-down menu. So we'll just click it. Now, as we have shared in other videos also, the first thing it is asking the input range. By default, it is taking this number also and it is leaving 13. So we can customize this range by choosing this. And we all know that in first row of the chosen area is our labels. So we'll tick it. Level of significance matches, which is given in the question. So we will not change it. Output range in this particular domain only we want, in this particular sheet we want, but little down. So maybe I'll click here and then OK. So the moment I put OK, you can see that two tables are arriving as a result. So let's have a look at both the tables. First, I will tell you the magical values which you have to see, and then I'll explain it little further in case you want to know about this. So first, we can see that in in this particular first table, which is talking about the summary, in summary, it's just telling us that in car 1, there are 4 number of observation, which you can see here. In car 2, there are 5, and in car 3, there are 6 number of observation. The average of the mileage is, the sum of the mileage is this, and the average of mileage is this. So we can see the average is, of, in case of first car is 14.8, in second is 13.38, 12.86. Any guesses? Do you think that these three numbers are comparable, or the difference is appearing on the table is just by chance, or there is some meaning to it? Let's find out. So this table 2 will help us in finding out whether this difference in these three average is just due to chance, or it actually meaning something. So there are two methods to find out that. The one method is called table value method, and the other method is called p-value method. So the decision criteria under both the method are different. In table value method, we compare the F value, which is a test statistic, or we can say here perform the test, or we can name this column as calculation of test statistics. And in case of ANOVA, it is F. So F test is showing the test statistic of one-way ANOVA. So what we are going to do, we are going to compare this F value, which is a calculated value, with the F critical value. So this critic means critical value. So I'm just highlighting it. So we need to compare these values. So how do we compare it? What is the meaning? So the decision is simple. If F value, or in bracket you can write calculated value, is more than the table oblique critical value, we reject null hypothesis. Or you can say that we fail to accept the, or we fail to accept the null hypothesis. So this is the way we generally do it. This is the decision criteria. I am just making it a little more readable for you. So this is the decision criteria. So that means we need to compare the F value. So in this method, we compare F value with critical value, because in this particular table, critical word is given, and I finished this table by writing critical with critical value. We compare it, and the decision criteria I have mentioned in the next line, which is F value is we compare the F value with the critical value. So in this case, we can see that F value is 29.109, while critical value is 3.88. So clearly, the calculated value is way more than the critical value. So what would be the criteria? In that case, we will reject the null hypothesis, or we will write that we fail to accept the null hypothesis. So we know that 29.01, even if we round it off, it will become 2, is greater than 3.88, which is its table value. So in that case, we will reject the null hypothesis. However, we don't write, we try to avoid writing this phrase, rejection of null hypothesis. But depending upon what you do, we can also say we fail to reject the null hypothesis. Now coming to the second criteria of for making a decision criteria to accept or reject the null hypothesis is p-value method. Let me highlight these two methods so that you can clearly identify it. So in p-value method, we compare the p-value, which you can see here, with the alpha value. So in this method, we compare the p-value with the alpha. Alpha is nothing but the level of significance. So in this case, what you will do, since you can see it's a very small number, and if you take it to the number, it will be 0. So clearly 0 is, and what is the criteria? If p-value is less than alpha value, we reject the null hypothesis, right? And in this case, you can say that p-value, p point is less than 0.05. So clearly, it is the case of rejecting the null hypothesis. So for your future clarity, I write p-value is less than alpha value. So either we take the table value method or the p-value method, the result will be same. So in this case, what is the decision? Step 4 is our decision that we are rejecting null hypothesis. Rejection of null hypothesis automatically says we are accepting the alternate hypothesis. At least based on our sample, we are accepting the alternate hypothesis. So if we need to write it, we will say that since the table value exceeds the critical value, or p-value is less than 0.05, we failed to accept the null hypothesis, meaning there is a difference in the average mileage of cars. At least one car performs differently from others. So this is the way we conclude this particular one-way ANOVA. I have given one other example, and one of the difference which I have made in this particular example is that I have taken the equal number of n in this question. That doesn't impact any kind of calculation thing. It's just that uh, any form of question you can get, the n size could be equal in all the observations, like in their 10 observation, 7 observation I think are there, 7 to 8 observation, and 8 observation in each case. Here different number of observations are given in each case. Rest everything is same. I hope you are able to understand this particular concept of one way ANOVA. Thank you so much.